Okay, so an example of the side theorem is shown by these two examples. So in the first one, you will see that this triangle is congruent to this triangle because this side is congruent to this side, and this side is congruent to this side. And then you wonder, what is the third side that is congruent to the other third side of the other triangle? And that would actually be this one, okay? Because you can see in this whole shape, all right, which this shape would be a rhombus, right? So this leg of one triangle is congruent to a leg of this triangle because of the reflexive property, okay? So the reflexive property makes this triangle and this triangle, the third leg of each of them, congruent, okay? So this triangle is congruent to this triangle by side, 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 all right? And then over here in the second example, you can see that this leg is congruent to this leg. Okay, so this leg congruent to this leg, and this leg is congruent to this leg, and this leg is congruent to this leg. Therefore, these two triangles are congruent to one another by the side, side, side theorem. And then moving onwards, for the side angle side theorem, these are two examples that support the side angle side theorem, okay? And so these two triangles up here are congruent to one another because of side angle side. All right, so again, the theorem states when two sides and an included side of one triangle are congruent to two sides and an included side of another triangle, then the two triangles are congruent due to the theorem side angle side, okay? So as you can see, this triangle, this leg is congruent to this leg, okay? This leg is congruent to this leg, and this included angle is congruent to this included angle, all right? So therefore, these two triangles are congruent to one another because of the side angle side theorem, okay? And then a second example down here is similar. So similar to the reflexive property that we used earlier, but we'll look at that last, okay? So this leg of that triangle is congruent to this leg of this triangle, okay? And then obviously these angles are congruent to one another as, supported by our diagram there. And then this leg of this triangle is the same as this leg from this triangle. So this is the same leg, and therefore this third leg of each of these triangles are congruent to one another because, again, of the reflexive property. Okay, so if we have two sides and an included side of one triangle congruent to two sides and an included angle of another triangle, these two triangles are congruent by the side angle side theorem. Okay, so some examples that prove the ASA theorem are as seen here. So in the top example, you see that this angle is congruent to that angle. This side is congruent to this side, and that angle is congruent to this angle, okay? So you have this is congruent to that, and this is congruent to this, and then this angle is congruent to this angle. And actually, the bottom most angles should actually have this. Okay, so to not confuse that this angle is the same as that angle. So we just want to make it obvious to distinguish this angle from that angle, okay, because they measure different degrees. So again, this angle is congruent to that angle, this side is congruent to this side, and this angle is congruent to this angle. And therefore, these two triangles are congruent by the angle side angle theorem. And then in the next one, we have this angle, which is congruent to this angle, this side, which is congruent to this side, and this angle that is congruent to this angle. And therefore, these two triangles are congruent by the angle side angle theorem, okay? Okay, so for the angle side theorem, again, we have two examples shown here. So in the top example, you can see that this angle is congruent to this angle is congruent to this angle, and this side is congruent to this side. And later examples, we're going to do actual proofs together. So eventually, I mean, they're gonna have some givens, and then other parts of the triangle you're gonna have to prove as to why that's congruent. So, you know, just for demonstration purposes, I'm showing you like, you know, this is congruent to that, that's congruent to this, and that's congruent to that. So there really isn't much for you to figure out, but it's just to explain this theorem. But in later examples, we're going to actually work through a proof and prove, you know, what qualities makes one triangle congruent to another. And then in this example, you have these two triangles right here, all a part of this one figure. Okay, so this angle is congruent to this angle, and this angle is congruent to this angle. And again, these two triangles share this side. So again, that is known as the reflexive property. And therefore, this triangle is congruent to this triangle by the angle side theorem. Okay? And then lastly, for the hypotenuse leg theorem, again, this is only for right triangles, okay? So that's something that's important to remember. You can't do this if, you know, the triangle is isosceles or equilateral. It has to only be right triangles. So in the top example, you can see that this side is congruent to this side, and this hypotenuse is congruent to this hypotenuse, and again, they're both right triangles, okay? So therefore, this triangle is congruent to this triangle by the hypotenuse leg theorem, okay? And in this bottom example right here, we can see that there is one right triangle here and one right triangle here, okay? And they both share this side right here. So again, that would be the reflexive property, where a leg from this right triangle would be congruent to the leg from this right triangle because of the reflexive property right there. Okay, and then we have the hypotenuse of this right triangle and the hypotenuse of this right triangle that are congruent to one another. So therefore, these two triangles are congruent to each other by the hypotenuse leg theorem. So here they give you everything that you basically need. There's no like information or evidence that you need to use to prove why certain angles are congruent, why certain line segments are congruent. Everything is given to you. But if you did want to go a step further and kind of analyze and see, you know, why certain criteria would make the angle congruent in this case, or the line segment congruent in this case, that's always good to know as well. So in this example, if this wasn't given to you, you would know that this angle is congruent to this angle because vertical angles are always congruent. Okay, so that is a criterion in geometry that you just need to know. And so, if they did not give that to you, you would know that by that simple geometric theorem, which is that vertical angles are congruent. Okay, and then similarly, these angles are congruent because you could basically assume that these lines are parallel to one another. Okay, so if you draw them to continue like so, okay, and then you have this line intersecting, right? This line is intersecting these parallel lines. You know that alternate angles of two parallel lines, alternate angles of the intersecting line are congruent. Okay, so that's just another theorem within geometry that you would study and know. But in this example, because this is a introductory proof, they give you the angles and the line segments that are congruent, so there really isn't too much analyzing and critical thinking that you need to do because it's all given for you right here. Okay, so we can see that angle B is congruent to angle E. So that's going to be our first statement. Okay, so angle, and we can't say angle B and angle E because even though it's easier to say that, we want to be very, very specific. So we're going to say angle AB, and sorry, this is not given to you, so we're going to make that C. Sorry, I should have written that there. So angle ABC is congruent to angle ECD. Okay, and the reason for that is because it's given. And then this angle is congruent to this angle because of vertical angles, but in this case they gave it to you, so we're not going to use the vertical angles explanation. We're just going to say given as well. So angle BCA is congruent to angle DCE, and again, it just helps you know, if you write it out this way, that we're specifically talking about the angle in this triangle and then the angle in this triangle. So that's why we have to write it like that. And this again is given to you. Sorry, this should be 1 over here, and this is 2 given. Okay, and then this line segment is congruent to this line segment, and again, it's given to you. So line segment AC is congruent to line segment DC, and it's given to you. And now with this, we have enough information to know why these two triangles are congruent. And if you think about it, we have these two angles, which are congruent to the corresponding angles of this triangle, and then this line segment is congruent to the corresponding line segment of that triangle. So if you think about the theorem that would postulate for these two triangles to be congruent, it would be the angle-side theorem. So we would say that triangle BCA is congruent to triangle DCE because of angle-side is congruent to angle-side. Okay, so that is that. And then moving on, so in this example, they don't give you all the information that you would need, okay? So we can clearly see that this line segment is congruent to this line segment is congruent to this line segment, and the different points are not labeled, so let's just do that quick. Okay, so the missing piece of information that we would need to know, we'll do that shortly. Let's just, fill in what we have here. So we're going to say that line segment AC is congruent to line segment CE because that is given to us. Okay, Let's keep everything color-coded. And then we are going to say that line segment BC is congruent to line segment DC. And again, that is given to us. And then if we look here, so we need one more piece of information, right, to postulate that this triangle is congruent to this triangle. We need to figure out what that piece of information is, though. We don't have that here with us. But again, earlier we talked about, in this example, that vertical angles, right, are congruent to one another. So if we look again, we can see here that there is another vertical angle, okay, and that vertical angle is congruent to that vertical angle. So we can say that, you know, the angle from this triangle is congruent to the angle from this triangle. So angle ACB is congruent to angle DCE, okay, and that is because vertical angles are always congruent, okay? So now we have enough to state why this triangle is congruent to that triangle. And so if you look at it, this triangle is congruent to this triangle because this side is congruent to that angle is congruent to that, and this line segment is congruent to that line segment. So this triangle would be congruent to that because of side, angle, side, okay? So we would say that triangle ACB is congruent to triangle triangle DCE because of side, angle, side is congruent to side, angle, side. Okay, and then we have two more examples here. Let's go to number 3. Okay, so number 3 looks like they give you quite a bit of information, so that's good. Okay, so we can see that this line segment is congruent to that line segment, and this line segment is congruent to this line segment, and this is congruent to this line segment. So okay, so this is the next example that we're going to work with here. Okay, so let's read. It says in the prompt that given angle ACB and angle DCB are right angles, okay, as we can see here, and line segment AB is congruent to line segment BD, state why triangle ABC is congruent to triangle DBC. Okay, so if you look at this triangle over here, again, they're saying that this line segment is congruent to this line segment, and these are both hypotenuse. And the reason why is because these are both right angles. So any leg that is directly across from the right angle is going to be the hypotenuse of the right triangle. Okay, so again, any leg that is directly across from the right triangle is the hypotenuse of that right triangle. So this hypotenuse is congruent to that hypotenuse, and this angle is a right angle, and this angle is a right angle. So we know that right angles are always 90 degrees, okay? So right angles are always 90 degrees, and we know that these are congruent to one another because this is 90 degrees and this is 90 degrees, so they're congruent. And then lastly, we know that this leg is the same leg for each triangle. So this leg is a leg of triangle ABC, and this leg is also a leg of triangle DBC. So therefore, this leg is the same. It belongs to both triangles, so it has the same distance no matter what. So that's the reflexive property right there. So basically, we know that these two triangles are congruent to one another. So we're going to say that angle ACB and angle DCB are right angles, and that's because that's given to us. And then line segment AB is congruent to line segment BD, again because that's given. And then BC is congruent to BC because of the reflexive property. So now we have enough information to postulate why triangle ABC is congruent to triangle DBC, and that is because of the hypotenuse leg theorem. Okay, so triangle ABC is congruent to triangle DBC because of the hypotenuse leg theorem. Okay, so hypotenuse leg is congruent to hypotenuse leg. Okay. Okay, so we're gonna do some practice questions now. So let's look at number 1 over here. The beginning part, it says, B is the midpoint of AC. Okay, so B, right over here, is the midpoint of AC. Okay, state why triangle ADB is congruent to triangle BGC. Okay, so we know that a midpoint is going to divide a line segment into 2, which means that this line segment is going to be congruent to this line segment. Okay, so we have to start by writing the statements first. Okay, so the first statement, if you look over here, it shows that line segment AD is congruent to line segment BG, and that is just given. So what you're going to do is you're going to write AD line segment is congruent to line segment BG. Okay, and the reason for that is given. Okay, because it is literally given to you. All right, and similarly, it looks like line segment BD is congruent to line segment CG. All right, and that is also given to us. So you would put that in there as well. So line segment BD is congruent to line segment CG. And again, that is because it's given. Okay, so now it says that B is the midpoint of AC. Okay, so if B is the midpoint of AC, we know that a midpoint divides a line segment into 2 equal halves. So therefore, line segment AB is going to be congruent to line segment BC. All right, so we can write that in our statement that line segment AB is congruent to line segment BC, and the reason is because a midpoint divides a line segment in equal halves. Okay, so now if we look at everything, we can see that this side is congruent to this side, and this side is congruent to this side, and this side is congruent to this side. So what theorem would postulate that this triangle is congruent to this triangle? And And so the answer would be the side theorem. Okay, so we know that these two triangles are congruent through the side theorem. So we can say confidently that triangle ADB is congruent to triangle BGC. And the reason is because side is congruent to side. Okay? All right, so that's the first example done. And now we're going to move on to example. We have this triangle and this triangle. We want to prove why triangle ABC is congruent to triangle DBE. We are given the information that AC is parallel to DE. So we want to prove, and then we have this line segment is congruent to that. That's also given. We want to prove why triangle ABC is congruent to triangle DBE. Okay, so they don't give us too much information, but they give us evidence and a little bit of, some hints as to why we can evidently prove why that triangle is congruent to this triangle. Okay, so if we know that AC is parallel to DE, and this is the line that intersects, we talked about earlier how the alternate angles of parallel lines that are, intersected by a line itself, the alternate angles of parallel lines are congruent. So therefore, this angle is congruent to that angle. Okay, and then earlier we also talked about how vertical angles are congruent, and over here we can see that there are two vertical angles. Okay, so therefore these two vertical angles must be congruent to one another. So with all of this, we definitely have enough information to solve why triangle ABC is congruent to triangle DBE. And so first we're gonna, list what we were given. So we were given that line segment AB is congruent to line segment DB. And again, that was just given to us. Okay. Then we were given that line segment AC is parallel to DE, and from there we were able to see that the alternate angles of interior parallel lines are congruent. So we therefore can say that angle ACB is congruent to angle DEB because, keep it color coordinated, alternate angles of interior parallel lines are congruent. Okay, and then the third one is that angle ABC is congruent to angle DBE because vertical angles are congruent. So therefore, we have enough information to prove why triangle ABC is congruent to triangle DBE. And the reason would be because of these two angles, which are congruent to the corresponding angles of this triangle, and then this side of line segment AB is congruent to line segment DB. Okay, so this triangle is congruent to this triangle by the theorem that postulates angle, angle, side. So angle, angle, side, congruent to angle, angle, side. Therefore, with these three criterion, we know that these two triangles are congruent to one another. Okay, so triangle ABC is congruent congruent to triangle DBE because of angle side is congruent to angle side.